Hi, I'm Andrew from Alpine Home Air Products. This is a central air conditioning installation video. Now if you're watching this video, you probably have already installed a central air or you're thinking about buying one. In either case, this is the video for you. We're going to show you exactly what you need to get the job done successfully. The tools, the supplies, and the know-how to have a successful installation. Now today we're at the home of someone who's going to get a brand new central air and you're going to watch us install it. And throughout the course of this, you'll see exactly how you can install your own central air conditioner successfully. You'll do the bulk of the work yourself, but the last 10% will be finished up by a professional contractor, which will cost you between $100 and $200 probably to complete the installation. But rest assured, by the time this video is over, you'll have the confidence to install your own central air conditioner. Let's get started. Here we are in the basement of the home where we're about to install the central air. Now let me show you what tools you will need to install it. Here's the tools that you'll need. What we have here is an L-square. These are sheet metal shears. You cut the sheet metal with these. If you don't have a pair, we do offer some on our online store. These are sheet metal benders. You don't need them, but if you had some, they'd be handy. Wire cutters, wrench, a couple of screwdrivers. These are hex nut drivers. This is a tubing cutter. A couple of hole saws, approximately around 2 inches, one or the other. We're going to use these to cut through the side of the home. Tape measure. If you have a set of drill bits, you can use that. I'm using an auger style, which will replace several different size drill bits. This is a sheet metal screwdriver. It'll hold the sheet metal screws and allow us to run those into the sheet metal. Some wire nuts, and we've got the tape measure and a drill. Okay, what we have here is a supplies package. Now you already know what tools you'll need, but you'll need some other things to get this job done. Well, we've made it convenient for you by creating this supplies package, which will provide just about everything else that you'll need to install your central air. All comes conveniently put together for you. Let me tell you what some of these things are, and then later in the installation video you'll see exactly how they'll be used. But first I'll start with the sheet metal here. To get the evaporator coil to fit inside your furnace, you'll have to do some custom sheet metal work. We'll talk more about that in a bit, but let me just tell you that these sheet metal pieces here are already prefabricated and cut to get you pretty close to what you'll need to do. All you really need to do for the most part is just trim them to make your coil fit. So having these pre-made sheet metal pieces is going to help your installation quite a bit. Some of the other things we have are tubing. This is 1/2 inch drain tubing. This is low voltage wire. Now this is 2 conductor low voltage wire, and that will be for 24 volts. These are plastic tie wraps. We use those to secure wiring. Sheet metal screws. This is a sheet metal bit. We'll put this in our drill and it'll allow us to run the sheet metal screws in easily. That comes with some low voltage wire nuts. This is an evaporator drain fitting. This will end up hooking up to the tubing. A few copper fittings for hooking up to your line set. A couple of electrical spade connectors. And then we have here, these are plastic hangers. And we're going to be using these to hang some pipe. And these are made for the air conditioning trade. Here's what one of them looks like, and you'll see how we'll use those in a bit. Now there's different kits on our site that you can obtain depending upon which air conditioner you get. All of them have the same things in them. The only thing that differs from kit to kit is the custom cut sheet metal pieces. The pieces are cut depending upon which air conditioner you're going to be installing. And you can easily select and view those online on our site. And now let me tell you about what equipment you need. The actual air conditioning system pieces that come together to make your system that you will need to select from our website to build your air conditioning package. It's simple. All you need are 4 different parts that all come together. Let me tell you what those are. The first part we'll say is the evaporator coil. That's what we have right here. This piece fits inside your furnace or air handler, and they come in different sizes depending upon which size air conditioner you'll need. The second part of that is the line set. This is flexible copper tubing. It bends a bit, And there's two sets of tubes that make up a line set package. The smaller one, which is 3/8 in diameter, and then the larger one, which is 3/4 in diameter for this particular installation. There are larger sizes for larger air conditioners, and you'll be able to see exactly which one you need on our website for the particular installation that you have. So let me show you the other parts, the other two pieces that you'll need now to make up your complete air conditioning system kit. The third part of your air conditioning kit is the actual condensing unit. This part right here. This is the part that sits out in the yard. It has a pump inside it. It's the largest piece of the air conditioning kit, and it's the part that people simply usually refer to as the air conditioner itself. Now the condensing unit sits on this base which comes with it. It simply secures it on the ground, keeps it nice and level. And lastly, the fourth part of the air conditioning kit is these electrical pieces here, which consists of an electrical whip and an electrical safety shutoff disconnect. Okay, that concludes all the equipment that you'll need to complete your air conditioning kit. We've also reviewed the supplies and the tools. Let me briefly show you what each piece does and how they work together to create an air conditioning system. Now what we have here is the condensing unit again. The condensing unit is essentially a large pump. Now this piece sits out in the yard, and when the air conditioning comes on, the pump turns on, there's a fan inside here and a set of coils, and what it does is it circulates refrigerant, which is a liquid or a gas, through this set of pipes. Those set of pipes go into the home and they hook into a coil. That coil is mounted in the air handler or in the furnace, which gets cold. This piece always sits outside in the yard. It's the main portion of the air conditioner. It's the condensing unit. Let's go down in the basement and I'll show you what the evaporator coil does. Alright, back here in the basement, we're going to install the evaporator coil. We showed you what that was before. The evaporator coil mounts inside the plenum. Let me give you a quick rundown on what we have here, and it'll help in understanding what the evaporator coil does. What this is, it's a natural gas forced air furnace. It's called an upflow furnace. Now in this application, this is the back of the furnace here. The ductwork from this point up is considered the supply or warm air plenum. What we have over on this side is the return air or cold air plenum. What they each do is, there's a movement of air through the ducts and through the furnace, which goes like this. The air moves down from the home, sucked from each of the registers and returns, down through this cold air return system, comes into the bottom of the furnace, or air handler, in this case it's a furnace, comes up through the body of it, is heated in the wintertime, continues to move up through the supply or warm air plenum into the home and out through each of the vents and registers throughout the home. Well, in the summertime, the air moves the exact same way when you install the central air conditioning. Again, when the air conditioning comes on, the air will get sucked down through the cold air return, through the bottom of the furnace, up through the body of the furnace, but the furnace won't actually be on, no heat will be made. And then the air continues up through here and into the various parts of the home. Now the evaporator coil is going to be mounted inside this portion, inside the supply plenum. And again, here is the evaporator coil. What we're going to have to do is mount it right inside here. This portion becomes cold when the air conditioning runs. As the air then moves up through the coil, the air is cooled and that cold air is transferred into the home. As you can see by looking at the bottom of it, the air is able to move through this coil. And it's very similar to, let's say, an automotive radiator. Even though it looks solid, air can actually easily pass through these fins without really restricting the airflow. Now the way this coil is connected to the outside air conditioning part is by these two tubes here. Your line set or tubes will eventually get soldered onto this portion and connect the evaporator coil inside your furnace plenum to the outside air conditioning condensing unit. Okay, we're just about ready to start our installation. I want to mention at this point some specifics about this particular home and what we're installing here. It might be somewhat different from what you have in your home, but in most regards it'll probably be very similar. We're installing a 2.5 ton, that's the size of the unit, 10 SEER, that stands for Seasonal Energy Efficiency Rating, that's the efficiency, on a natural gas upflow furnace. Now you might have something a little bit different in your home, or you might have something similar. Particularly, the style of furnace or air handler you have will affect somewhat the specifics of your air conditioning installation. Again, this is an upflow furnace. Now you might have a downflow furnace. What does that mean? It looks the same, but the air moves down instead of up. Or you might have a horizontal furnace, in which case the furnace is on its side. That would be more common in an attic or in a crawl space, in which case you would use a horizontal coil. Those are available on our website. They install very similarly. You may also have a heat pump in your home instead of an air conditioner. Now, although we're going over the specifics of this particular installation today, and you might have something somewhat different, I want you to understand this, that the specific techniques used to install are almost exactly the same no matter what installation application you have. There will be some slight variations. Those will be indicated in the instructions which come with the particular piece of equipment that you'll be purchasing. But what you'll see as far as the workmanship, the techniques, the supplies, the tools, they're all going to be relatively the same from one particular application to the next. So I think you'll find this video will be helpful for you no matter what you're installing. It's time to start installing this air conditioner. I'm ready. What do we do first? First thing we want to do is figure out where we're going to put this air conditioner outside the home. I've chosen to install it back here in this corner. Let me tell you how I chose this particular spot and how you can figure out where you want to best install or place the outside condensing unit around your home. There's several things to consider. First off, there's not necessarily a perfect spot or a wrong spot, but there's locations which are better than others. Some things you'll want to consider is first, the ground needs to be level and secure wherever you put the unit. You want to make sure that if you have the choice to keep the unit out of direct sunlight where the sun will be beating on it all day long. It's made to run in the sun if it has to, but it will become a little bit more efficient for you if you can keep it in an area that's a bit more shaded. Also, you want to make sure that it's not needlessly in a spot where it's going to have water pouring down on it constantly. Yes, it's an outdoor unit, it can be rained upon, but you don't necessarily want a gutter dumping directly into it. Another thing to consider is how close will it be relative to where your electrical circuit panel is for the home. Now, my particular installation here, I'm not that far away from the electrical circuitry panel in the basement, and that's in part why I've chosen this spot. I'm also out of a lot of direct sunlight here. Something else to consider is you don't want plants to be growing directly on it. You want to have a bit of clearance around it so that the air can flow around the unit. Once you've taken these things into consideration, you'll be able to come up with a spot around your home. Cosmetics, of course, is a consideration. You probably won't want it in the front of your home. You'll want it somewhere in the back or on the side. And lastly, you don't want to put it next to your gas meter or electrical meter. Most local codes say that you should stay within a 3-foot distance from those locations. So now I'm going to go ahead and level the ground back here, put the pad down, place the condensing unit, and I can get started from that point. You need to clear this bush out of the way a little bit. So we've leveled the spot here in the back, cut the bush out of the way. Now I go ahead and place the pad down, which the air conditioner will sit on. I want to make sure that the air conditioner will sit 6 to 10 inches away from the home. And if I'm going to be in a corner, as I am here, I want to make sure that I have that full 10-inch clearances at least on both sides. And I can see that I do. So I'll go ahead now and make sure my pad is level, and then put the air conditioning unit on it. going to cut a hole in the side of the house which will allow me to run the electrical and the line set piping from the inside to the outside. They'll both run through the same hole. It's going to be approximately around a 2-inch size hole. It doesn't have to be 2 inch exactly, but that's about the size hole that works well to run everything through. Where do you cut the hole? Any place that's going to be convenient, which is near the air conditioning system. Now for me, in my situation, I've decided to cut it right here. It's about 2 feet away from where the actual air conditioning unit itself will sit. Now if you can get it closer to the air conditioner, that's preferable. In this case, I'll end up running my electrical and my piping alongside the home and then up to the unit. So I'm going to go ahead and cut that unit, that hole now. But let me just mention this as well as to how you might know where to mark your hole so that you don't end up drilling into the house and on the other side find you've drilled right into the back of your couch or something like that. Now in this case here, when I drill this hole, I'm going to come out into the basement. And that's of course where I want to be in this particular situation. How did I know where to measure? Well, a trick to measure is to find something relative that you can see from both the inside of the home and the outside of the home and use that as a point of reference. What might you use? Well, let's take a look at what I've used here. We have a water spigot which is sticking out of the side of the house here. I can see that from the inside as well as the outside, so I can measure from that. I also have a little electrical hole over here where some telephone lines come in and out. I can see that from the inside in the basement as well as from the outside. Because I can see it in both places, I know if I measure 4 inches or 6 inches or whatever it is away from left or right, as well as up and down from those points of reference, I know that I'll be okay when I drill through on the other side. So I've marked my hole. I'm going to go ahead and cut it. As I said, I'm using a 2-inch hole saw. I'm going to start with this hole saw here, and it'll make a cleaner hole so I don't end up ripping my siding and making an ugly snag in it. And then after I start it, I'm going to switch to this bit here. It's more of an auger style because it drills a nice fast hole, although it's a bit rougher, so I don't want to start with it because it could end up tearing up my siding a bit. They're both the same size in diameter, but I'll start with this one, switch to this one, and make my hole. Now I'm going to measure and cut the hole where the evaporator coil will fit into the plenum. The evaporator coil has to fit inside here. How are we going to get this inside of here? Well, we cut an opening just the right size, and then we're going to mount it. And you'll see where the sheet metal comes in handy to do that. How large should the hole be in the plenum that we cut? About a 1/2 inch larger than the size of the coil itself. This coil I have is 13 inches wide, so I'm going to cut the width of the hole in this situation 13.5 inches. The height of this coil is 16 inches high, so I will cut the height of the hole 16.5 inches. And now I'll cut this area out. And then I'll use my sheet metal shears to cut along the line and cut this hole out. Okay, I've cut my hole. I'll mention at this point, you want to be really careful when you're working around the sheet metal. The edges can be very sharp, so please be careful not to cut yourself. Now we're going to go ahead and mount the evaporator inside here, the evaporator coil in here. How is it going to set inside here? It needs something to sit on. Well, we're going to build shelves that it sits on. I'll show you how we go about doing that. Now the evaporator sits inside here. I'm just going to show you how it fits for a second. Like so. But it needs something to sit on, as I said. I just want it flopping around in here at any old angle. So, we're going to build a shelf. And we build that out of these pieces here, which will come in the supplies package. There's 4 of these shelves. Each shelf is intentionally larger than what you're going to need, but all you need to do is trim it for the exact size for your particular application. The way it works is this. You use 4 shelves, one for each side that goes around the edge on the inside here. That's side 1. Use another one for side 2. A third one for the back, and then a fourth one in the front. Let me lay it out for you on the ground for a second, and then maybe you'll have an idea of what this shelf is supposed to be like. Here's the way the shelves might look. I'm going to lay it out here on the ground and give you an idea of how it might look once it's installed inside the plenum. There's a second side, a third side, and a fourth. So this is the way the shelf platform might look when arranged. And then the coil sits on top like so. It allows the air to flow through the coil, but not around the coil, and it creates a nice stable platform for it. And this is looking at the evaporator coil from the bottom. Now our objective is when we trim the shelves to make them just the right size for our application, that the shelf does not move too far in on the underside of the coil so that it begins to restrict the airflow, because the air will be flowing through the center here. Now for example, if we had the shelves come too far in, as they are the way I have them arranged now, there will be a very narrow opening that the air could actually flow through. We want the shelves to be further out so that they sit approximately like this, so that the full underside of the coil, this full opening, is exposed to the airflow. The air can then freely flow in here. So again, we want to trim our shelves so that they fit inside the plenum, and yet at the same time they don't come too far in or too far out so that the coil actually falls off. Starting with the back shelf, I'm going to go ahead and trim it to the appropriate length and install it. Then I'll put in both side shelves and the front shelf last. Now my back I measure as being 16 inches wide, so I'll go ahead and trim it 16 inches wide. I'm almost ready to put this back plate in. I can see that the width fits fine. I'm going to have to trim the length of it, or the depth of it. Now how high up or how low down should I put it? At this point I want to mention that we want to have the back plate, or the back shelf, about a ½ inch higher than the front shelf. The reason why is we need to create a pitch on the coil. Here's the coil again. Looking at it from the side, in an exaggerated way, we want to have the coil pitched towards the front. Now that's more than a ½ inch pitch. We want just a little pitch, but the idea is that it's pitched towards the front. The reason why is this bottom plastic piece here is a tray, and it catches condensate, or water, as it runs. We want that water to be running out this drain hole here as it runs. So to ensure that the water runs forward to the drain hole, we want the back plate to be about a ½ inch higher than the front plate, so that the coil is pitched downward and the water that collects in this plastic tray runs out the drain. And here's my back piece trimmed. It's ready to be installed on the back wall of the plenum, right about here. And you'll notice that I have that back lip facing downward, not upward. And now we have both sides in place. I've trimmed my front piece, and I'll put that in place. And now I'm going to go ahead and put some screws in each corner so we connect the plates to each other, and it just makes the whole thing a bit more secure. And now we can put the evaporator on our shelf, which is done. And there it is in. The next step is to go ahead and put the cover on. Now, in some applications, the cover may fit on flat, but in this particular application, the evaporator coil sticks out about a ½ inch further, so we can't put a flat cover on here. Let me show you what I mean. Looking at it from the side here, we can see that the evaporator at the bottom and at the top is sticking out so that we can't put a flush cover across it. In some instances you might be able to put the cover on flush, but in this case we can't. So let me show you what we do in a situation like this. We can see here that the evaporator, although it's pushed back as far as it can go, is sticking out about a ½ inch here at the bottom, and at the top it turns out to be 3/4 to almost an inch. So we're going to have to adapt the cover that goes on top. Let me show you how we do that. Now here is the cover which fits this particular evaporator coil, which came with in the supplies package. Now we're going to go ahead and just slide it on so I can show you how it fits. Now to make it fit properly, these copper lines here, if you need to bend them just slightly, you can go ahead and do that. And you get the idea now. We can see that the cover fits on, but we can't just go ahead and trim the piece just yet and screw the cover on, because again, the evaporator coil sticks out about a ½ inch or 3/4 of an inch too far. If it were to fit flush, and it may in your circumstance, you would simply go ahead and mark the edges of where you would trim this cover plate so that it would fit along the edges, and then screw it on to the front of the plenum, and you would be done. But in this situation, we're going to have to do something a little bit extra, and let's go ahead and do that now. So we're going to turn this cover now into what we refer to as a pan. It's a terminology to mean simply instead of a flat cover, the cover is going to stick out a little bit. And what I've done is transferred, as you can see on the back side of this with marker, some dimensions here. I've measured from the outside on both ends to create these two lines here. And then I've measured from the bottom to the top to create these two lines here. What I'm going to do is fold the sides up on the top and on the bottom, and then fold the outer lines as well, the opposite direction, to create this pan, which will be essentially a raised cover, which will allow for properly covering this part of the plenum where the evaporator sticks out. I'll go ahead and bend these now, and you'll see what this looks like when it starts to come together. I'm going to go ahead and bend up these edges here along the lines I have. Now, we said earlier you'll want to use an L square. Normally in a sheet metal shop, a heating and air company will have a large industrial bender, and that would be easy for them to make these bends. But this is 28 gauge sheet metal, and you can very well just make this bend with your hands on your own with something like an L square to create the straight edge. I'll show you here. Simply by setting the L square along the edge and just pulling it up along the lines to create a 90. And you can see we made that 90-degree bend there. I'll go ahead and bend all the other sides now too. I've made my bends in the cover. Here it is. It's the back side. And I have this little 1/4 inch lip I've made on top, which I've bent with these sheet metal benders here. If you don't have a pair of these, you can use a pair of pliers. And putting the cover on, we can see that it fits in place now. I'll go ahead and move it around a bit so that it fits securely, but we can see generally at this point, even before I do that, it fits. You'll need to do the same to create your custom cover so that it fits as well. What you really want to be concerned with is simply that it's nice and secure in place, and that the air is not going to be leaking out needlessly around the edges. A little bit of airflow in the corners is perfectly okay, but if you want, you can come back later and fill that up with a little bit of silicone sealant, and that would be just fine. Now, before I go ahead and put this cover on, so that it'll fit as flush as possible, you notice a little tab here at the bottom. I'm going to go ahead and break that tab off. It's plastic. I can do that in this situation because it sticks out about 1/4 inch, so my cover will fit up. I can go ahead and just break that off with a pair of pliers. Good, now my cover is secured in place and we're ready to move to the next phase. I'll mention at this point one thing you want to keep in mind when you're putting the screws in to secure your cover is to make sure you don't put any screws directly into the plastic tray here at the bottom. That is the condensate tray. What I mean by that is, as your air conditioning system runs, this whole coil inside here is going to get cold. And similarly to if you're having a drink of something nice and cold in the summertime and you set that cold glass outside on the table, water will begin to collect on it. Well, the same thing happens to this coil in the summer. When the air conditioning runs, it gets cold and water collects on it. Well, that water runs down the side of the coil into this plastic tray on the bottom. And then the water eventually will run out this little hole here, which will be connected to a drain tube and to a drain. You want to make sure that you don't put any screw holes directly into the plastic tray here along the bottom, because it could create a leak and water could come through that hole. Also, you note that the evaporator coil is sealed here. These two tubes are sealed shut. When your contractor comes to finish the job, he's going to unseal these and make the final connection, so you don't need to worry about that. The evaporator coil comes pressurized with gas in it. He'll take that pressure out when he comes. Great, now it's time to hook up our line set, which is these two copper lines, from here to the outdoors to the condensing unit in the yard. The large line set hooks up to the large pipe, and the small line set hooks up to the small pipe. Let's take a look at that path. We're going to run the line set from here down across the ceiling from here, and we're going to exit out this hole, which will take us to the outdoors. Let's do that. We're starting with installing the larger line set. The larger line set is also referred to as the suction line. Now, we're going to have to go ahead and unroll this, mount it then along the ceiling in this particular instance, and we're going to hang it by these little guys here, these hangers, which are in this bag and included in the supplies package. An easy way to unroll this is, maybe with your foot, hold one end down, and then simply unroll the coil with your hands as you go. And that creates a nice straight piece of tubing, which I can then hold up to the ceiling and secure as I move along. We'll start by sticking this end of the suction line outdoors first, and then connect it along the ceiling, securing it back towards the furnace. Now, to get the suction line outside, you notice that there's insulation on here. The reason why there's insulation is because as the air conditioner runs, this line gets cold and it will begin to collect moisture from the air. Water will collect on it, which could then drip, which can be a nuisance. So we can move some of this insulation off of here for now and later secure it back on with tie wraps or tape. It's easier if we take it off now, just a little bit, the part that's going to stick outside. And you can do that simply by cutting it with a knife or even just peeling it back as such. And then later we can move it back on and secure it. And then I'll stick a portion of this outside. I want to make sure I stick plenty outside, enough to make my connection for sure to the condensing unit sitting in the yard. I can always trim some off with my tube cutter. Now we'll go ahead and secure the line set to the ceiling with our line set mounting brackets, which would simply slide onto the line set, and then we've screwed it in place. It has two holes in it, one hole on each side. Okay, now we're back outside. Here's the line set that we pushed through the hole, and you can see we've got about 4 feet of line set. We're going to need to get this pipe, this line set 3/4 suction line, from here down to the condensing unit. Now it's soft copper, we can bend it a little bit, but we can't make sharp 90-degree bends in it or else it will kink. However, we have these fittings we can use. So what we'll do is we'll cut the line use these fittings. This is a 90-degree elbow, here's a 45, to create the pathway here and get the pipe where we need it to go, which is pretty simple to do, so we'll go ahead and do that now. Just want to mention, when we go ahead and cut this, that it's important to keep the inside of the pipe clean. We don't want to get any little bits of metal in there, dirt or water, because it's a sensitive environment inside the pipe when the air conditioning runs, and cleanliness and dryness is important. And connect the pipe into the condensing unit. And there we go. When you're bending your copper, you want to be sure, again, to make sure you don't crimp it. If you bend it too far, eventually the pipe will crimp and crush. Let me just show you. Here's a piece of copper. As I start to bend it a little bit too much, a crimp starts to occur, and at which point it eventually just gives way, and now I've got this big crimp mark in it. If this should happen to you, don't worry. It's not completely ruined the pipe. What you can simply do is straighten it out, use your pipe cutter to cut off the area which is crimped, and we've also included in the kit a coupling, which you can simply use to splice the pieces back together again, and you'll be fine. As with the large line set, I'm also now putting out the small line set. The small line set's a lot more flexible and it's easy to bend. So again, I've straightened a portion out, stuck it through the hole. Wanted to make sure I have plenty sticking outside to reach the condensing unit. And now I'll go ahead and straighten it out back towards the furnace. Hook it into the mounting brackets where I have the other line set run. And here's our small liquid line sticking outside. Now I've got about 4 feet. I can go ahead and I can actually make a 90-degree bend on this with less worry about it kinking. I still have to make sure it's not too sharp of a bend, but as you can see, it works out pretty well there. Now back at this end near the furnace, I've got both line sets coming down, and I'm going to go ahead and trim them so that they're a few inches beyond where I think they're actually going to need to connect. And that will get them ready for the contractor who will come in and actually connect them into the evaporator coil when he's here. For the insulation, I can cut through that with a knife. Before I cut it with the tube cutter. And there we go, it's ready for the contractor to finish it up. We're done with the line set now. Now it's time to do the high voltage electrical. A central air conditioner runs on 220 volts AC. And we have to be able to get that voltage from the main electrical circuit panel in the house, wherever it is, in this case it's in the basement, to the condensing unit outside. And the way we're going to do that, and what we recommend you do for your own installation, is to handle the electrical wiring, if you feel you're capable, and we'll show you how in this video, from the outside of the condensing unit where it hooks up into the home, right up near the main electrical circuit panel in your house, but have your contractor actually hook the high voltage wiring into the circuit panel. It's dangerous work potentially if you don't know what you're doing, so you want to have a professional do it. Let your heating and air contractor hook the high voltage wires into your main circuit panel, or an electrician. But if you're going to have a contractor come out to finish the last 10% of the job, just let them go ahead and do it. It won't take them long. So here we are outside. We're going to begin hooking up the high voltage electrical line from the outside toward the inside. And first thing I should cover is there's different thicknesses of wire referred to as gauges of wire, and there's different breaker sizes as well, which correspond with that. Depends upon which size air conditioner you have, what it's rated for. Again, this is a 2.5 ton air conditioner. You will need different thicknesses of wire and different amperages of breakers. Now don't get too confused. There's a simple chart on our site, which you can see, which will tell you what thickness of wire you need, as well as what corresponding size breaker, which will work with the air conditioner you're installing. And we'll make recommendations on our site for you if you've not yet purchased an air conditioner to recommend the correct electrical size wiring. Well, let's get down to it for the unit we have here. For the 2.5 ton, we're going to be using number 10 wire, and that's the thickness of the wire in this, what we refer to as a whip here, and that would correspond to a 30 amp breaker inside, but that's the part that the contractor is going to be handling when he does his part. But we do need to know that we're going to have to use number 10 wire. Okay, here's what we do outside. We have this box, which is part of your air conditioning kit. It's referred to as a disconnect, and it's a safety switch, and it's code to have a safety switch outside by the air conditioner. So we're going to mount that on the wall near the air conditioner, and we're going to have two whips running in and out of it, and we'll show you how that works. One whip hooks up to the air conditioner and then to the disconnect. The other whip hooks up from the disconnect, runs through the hole in the house, and we'll continue the electrical wiring from there all the way near the circuit panel. So where are we going to put the disconnect? Well, let's go ahead and choose that spot right now. Here's my disconnect. I'm going to mount it right about here on the wall. And the way I've chosen the location is because it's near the hole and it's also near the air conditioner. I want to make sure that it's plenty high enough up so that it's not in the way of a snow line. I don't want it to be too low down here. I want it to be up out of the way in case there's water or snow. They won't interfere with the electrical system that we have. See your local electrical codes if you're not sure where to install that. So I'll put it right about this height. And let me show you what the inside looks like. It has an on-off switch here at the top. Simply by pulling this knife out, as it's referred to as, and flipping it the other direction, it changes from on to off. I'll take that out for now. And also there's this little cover. I can pull that off and I can see the inside here, and there's different screw points where I'll be hooking up my wires in a little bit. And there's also these holes that will allow me to mount it right up against the wall. Before I do that though, I need to punch out some holes where my electrical whip is going to connect into. The whip will connect to either the sides or to the bottom. So I'm going to choose the side holes here to punch those out before I mount it to the wall. I'll go ahead and do that now. Got my box mounted to the wall. Now I'm going to hook the whips into it. Got one whip. It's going to go in each hole that I've punched. These whips are watertight. That's the reason why we use them. We don't want to just use any old wire outside. It's watertight so it can withstand the weather and we don't have to worry about that. Now you'll notice one end has a 90 on it and the other end's straight. Which end should you use? Whichever end is more convenient for your particular application. So you go ahead and unscrew the little nut that comes with it. Stick the wires through the hole. Put the nut back on the other side, and then simply tighten it back on. I'll go ahead and put some pliers on it and snug that down. And then I'll do the same thing for the other side. The other side I'm going to use the 90 because it works out a little bit more conveniently for me for this particular application. Go ahead and put the nut back on and tighten it down. Okay, now it's time to hook the wires up inside the disconnect. Where do we put these wires? It's not that hard. In fact, it's easy. Why don't we start with the green wires first? The green wires are the ground wires, and we're going to hook those up to these two lugs right here in the center. But first we're going to have to trim the wires and strip them. So let's go ahead and do that now. Go ahead and trim them. And then I'll strip them back about a ½ inch to get the insulation off. As so. And then hook them up under either lug. Doesn't make a difference which green one goes where. Simply sticking the wire underneath the lug. Once I get it in place, I'll go ahead then and tighten it down. I want to make sure it's nice and snug too. This is high voltage, we want good solid connections. And then I'll do the same thing with the other green wire too. Okay, now we're going to hook up these two wires here. What we want to do next is the whip, essentially, that goes to the inside of the home, not the one that runs to the air conditioner, the one that runs to the inside of the home. We're going to hook up those two wires now. Where do they go? Inside here, in the center, there's two terminals that say line. We're going to put either one of those into either connection. We can put the red one on the right or the red one on the left. Doesn't make a difference at this point, as long as we get them hooked up where it says line. So again, I'll go ahead and I'll cut the wires to the right length. Just trim them off a little bit. And then strip them. Again, strip about a ½ inch off. We'll go ahead and do both of those. And then simply stick them under the screw. Back the screw out first. And in this case, I'm going to put the red one on the right. Once I get it under, tighten the screw down. And again, make sure you tighten that down nice and securely, because high voltage needs a good solid connection. And then I'll do the same thing with the black one on the other connection that says line next to it. Alright, we're almost done. We have 2 more wires to go, and unfortunately there's only 2 spots left, so it's probably not going to be too hard to hook up now, is it? Which one goes where though? Well, on the outside here we can hook up the black or the red. Which was going to go on either side? Well, we already have the red wire to the right, so we want to correspond the same colors. That means I'm going to take the remaining red wire and hook it up on the remaining right lug. I'm going to take the remaining black wire and hook it up on the left side by the other black wire. So the colors correspond. The 2 reds and the 2 blacks correspond to each other. I'll go ahead and do that now. And now I'll stick this end of the whip that's going to connect up to the main circuit panel inside through the hole into the basement. That's it, we're done hooking up the wires in the disconnect. All we have to do now is put the cover back on. Inside like that, and then we'll put the on-off knife back in. I'm going to put it in the off position. The contractor can turn it on when he comes out and finishes up the wiring and starts up the unit. Okay, we've got the line set coming inside now, down in the basement here. This is on its way towards the main electrical circuit panel, which is just a few feet away over here. I'm going to now hook this into a junction box. This is a standard 4x4 electrical junction box. I'm going to punch out a hole on either side so I can connect into and then out from. I'm going to screw the box up to the floor joist, and then the wire coming out is going to be flexible Romex. That's a brand of flexible wire such as we see is already mounted right here. Check with your own local code to make sure that a flexible wire is appropriate and in what circumstances you can do so. Here we could run flexible Romex as long as it's above the bottom of the floor joist up inside here. If we have to go perpendicular to the floor joist, we need to run holes through the floor joist and then run the Romex through such. In some areas you have to run everything in solid conduit pipe and then run a flexible wire inside. Again, the gauge of the wire we're using is number 10 because of the size of the air conditioner we have here. I'll go ahead and mount my box now. Okay, now I'm going to open up the air conditioner access panel. I've just taken off the last of 3 screws, which allows me to remove the cover. And this is where the electrical will hook up into. This is where the whip is going to connect down here in this hole at the bottom. And similarly to the way we connected to the box, we simply remove the end piece here. And there's 2 washers that come with the whip. One washer will go on each side of this plate here that it connects to. So I put one washer on. And why don't we get a close-up here on what we've got going on. We connect into the hole. Put the second washer on. And then lastly, we put the nut on top here. And go ahead and tighten that down. I'll put a pair of pliers on here and tighten that in a minute. But you can see that that secures the wire in place. So I'll tighten that up and then we'll connect the electrical wire. Okay, so here are the 3 wires. The green one is ground, and it gets connected to this lug right here. So I'm going to shorten that just a bit, strip it, and then unscrew the lug connector and hook the wire up under that lug. Tighten it down nicely. There we go, nice and secure. Which leaves us with the 2 high voltage 220 volt is what it will be when we connect it, number 10 wires. They go on either side of this contactor. Now there's no power in here now, so I can go ahead and touch this and it's nothing I need to worry about. We are going to hook up either wire to either side. For continuity, the left side, at least from where I'm at, I suppose it's the right from your view, the red wire will match with the red side of the contactor and the black wire will match with the black side of the contactor. So we'll go ahead and do that now. Now included in your materials package for the air conditioning kit will be a couple of these spade connectors, which we'll put on the end. I'm going to go ahead and shorten these wires just a bit. Strip this back about a 1/2 inch on both of these. I'm going to put on a spade connector. Spade connector will slip over that number 10 wire. And I have a crimping tool here which has a little bump in it, which allows me to hold this in place, but I could also use a pair of pliers and similarly do the same. By squeezing down here, it crimps itself and holds the spade connector on to the wire. I'll do that again with the black one as well. And then I simply hook them onto the spade connector, which is on the bottom of the contactor. Now alternatively, there are screws, if you see here, that we could strip the wire and put it under the screw, but I prefer the spade connection myself. There we go. The high voltage electrical is now done in the panel. All that remains now is the low voltage, which is 24 volts, which we'll hook up over here. Let's get started on that. Here's my number 10 Romex and my connector. I'm going to make sure I have enough sticking in the box. I can always trim it. I'm going to strip off the outside insulation here, hook up my connector, and put it in the box. Now I'll hook up a Romex to box connector. This is something you can get at any hardware store. Simply tighten down the connector here, the screwdriver. When you're hooking up to Romex as such, you want to make sure that you don't tighten this connection down too much, because you can end up pinching the wire and cutting into it. We really don't want to do that. We want to just tighten it down just a bit, just so the connector doesn't fall off here. And that will be sufficient. Like so. Then we'll take this nut off the unit, put it in the box, put the nut back on, and there we go. And I'll tighten that up with a wrench. And I've made my connections: green ground to copper, which is the ground, the black to black, and in this case the red corresponds with the white. It just happens to be the color of the insulation, but it's the remaining colors, and so they match up together. And I'll put the cover on now. Here's the main circuit panel for the home. This is where the main power is at. We need to hook our 220 volt wire into to eventually get the electricity out to the air conditioner in the yard. But again, this is not the part that you're going to do unless you just happen to be an electrician or you're very experienced with this type of thing already. We don't want you to do this part. We want you to have your heating and air conditioning contractor finish this part of the job for you. But you do need to get the wiring close so that the contractor can simply connect it properly when he comes to finish the job. So I'm almost there. I just need to cut a length of it and run it close. What I'm going to do is drill a couple of holes through these floor joists up above, run the wire down, spool some of it up, and then I'm done with this part of the task. Which brings us to the 24 volt wiring now. The high voltage portion is done. We're going to move on to the low voltage, which is this. It's 2-conductor 18 gauge wire, and it's going to run between the condensing unit outside and the furnace or air handler inside. So I'm simply going to run this out the hole and then attach it back along the ceiling, however is convenient, back toward the furnace. This is low voltage, again 24 volts, so I could simply tie wrap it along my line set and I don't have to be as concerned about the specifics of how it's mounted. This is the 2-conductor 24 volt wire, which is included in the supplies package, which came with your air conditioner. I'm going to hook it up now at the condensing unit simply by running it along the line set area. And let me show you how it connects into the condenser. We stick the wire in under here, and we're simply going to strip this and connect it to these two purple lines right here. Easy enough to do. So we'll take the insulation off the outside, which exposes the two wires. We have a red and a white. I'll strip about a ½ inch off of either of those, like so. And then there's some blue wire nuts, which are included in the supplies package. And it does not make a difference which color wire goes to which, so hook them up on either one, and that will be just fine. There's one. There's the other. And that completes the electrical portion in here. We can go ahead and put the cover back on. We'll screw it in place and this is done. So I have the cover on the condensing unit. Now I have this line. Where am I going to secure it? Well, the connections have not yet been soldered by your contractor at this point. But what you're going to do is, after the contractor solders the connections, you're going to take the foam insulation, which we pulled back from the portion inside, and go ahead and reapply it, like so, to the larger suction line. And using the tie wraps, which are included in the supplies package, tie wrap that in place. Also, we'll take the 24-volt wire and secure it along the same line. And again, using our tie wraps, we'll secure that in place as well. The idea being that it's not loose and flopping around. And I'll do that along the whole length here to make it nice and tidy. And we'll tie wrap it along the line set inside here, so the wire is nice and secured. And before you start working on your furnace, make sure you turn the power off. Here's the other end of the wire coming down from the outside and ending up back here at the furnace. Now, how are we going to connect it up? I'll show you. It's easy. We'll take the covers off first. And again, we want to remember the power to the furnace is off at this point. And we're looking inside where the control wiring is currently hooked up. And in this furnace, it's in the lower portion here. How do you know where that hookup area is? I'll show you. Let's take a look here. Okay, this is the portion of the furnace that we're looking for, or the air handler. And this part here has letters, which shows what each of these terminals are designated as. You'll see the letter C, Y, G, H, R, and W. Now we are going to hook up the other end of this 2-conductor wire here to the C and the Y. It's really as straightforward as that. So I'll go ahead and trim the wire piece we have here. Bring it into place. Strip the end. Bringing the insulation off. And I'm going to hook it up under those screws, the C and the Y. Again, it doesn't make a difference which color I use in this particular instance. So I'm going to put the white for the C, and for the Y, I'm going to use the red. There we go, that part's hooked up. So now we have to hook up the thermostat to the furnace so that it will be able to turn on the air conditioner. Now, how do we do that? These two wires over here, which are currently hooked up to W and R, are the thermostat wires. They run from the furnace all the way upstairs to the thermostat on the wall. Well, we need to hook up a couple more wires to make that run the air conditioning now as well. Now we can see in this thermostat wire casing, there's a couple of unused wires. We're going to use a couple of those wires now and hook them up to the furnace, and then at the other end upstairs we'll hook them up as well. We need a total of 4 conductors to run from the furnace to the thermostat to make the unit run. We already have 2, and they're hooked up at R and W. The red for R, the W for white. We'll leave those there. All we need are 2 more, and we're going to use, in this case, the yellow and the green. Now it's easy to figure out which goes where, because the green hooks up to the G, G for green. The Y hooks up to, take a guess, the yellow, Y for yellow. It's really as simple as that. So I'll go ahead and do that now. There, the low voltage wiring is all hooked up now. The 24 volt control wire from the condenser all the way to the furnace, as well as the thermostat wiring down here up to the thermostat upstairs. That completes the 24 volt portion from here. The last part is I just need to go upstairs at the thermostat and properly hook up the wires there. I want to note at this point to you, if you for some reason don't have the lettering configuration as we showed here, don't worry, your contractor can help you. Simply leave the wires that you've run over to the furnace available for him to cut and splice into the furnace properly, and I'm sure it wouldn't be much difficulty for him when he's here to help you with exactly where they go. Let's go upstairs to the thermostat. So now we're upstairs here in the home and we're at the thermostat. We're installing a new thermostat in this situation because the old one didn't have air conditioning capability. So we have a nice new digital one which will allow us to control our new cooling system. If your current thermostat doesn't have cooling, then you're going to need to provide for yourself a new thermostat. Any thermostat that has air conditioning capabilities will work for you, such as the one we're using here. So at this point all we've done is taken the old one off the wall and screwed the new one to the wall. Let me show you how the wiring hooks up. It's pretty easy. Pretty much like downstairs, this is the other end of the wires, and they will hook up according to their corresponding color letter. So the G hooks up to the green, the Y hooks up to the yellow, the W hooks up to the white, and the R hooks up to the red. Now in this particular thermostat, there's 2 R's. One says RH and one says RC. But there is, what you'll notice here, a little jumper which connects both of those together, which is appropriate. If you have a thermostat that has an RC and an RW, you'll probably need a jumper to connect those. But see your thermostat's installation instructions to be sure. I'll go ahead and hook those up at these terminals now after I strip them. And the thermostat's all done. Okay, this installation is coming near a close. Things are moving along really well. What we're going to do now is hook up the drain and the drain tubing. This little fitting here is a condensate drain fitting. It hooks up to the 1/2-inch drain tubing, which comes in your supplies package. Let's go ahead and screw this in here. Nice and snug, and then this tubing simply hooks up on the end. Now I'll run this over to the floor drain in the basement. Now what if you don't have a floor drain in your basement or wherever you're installing, someplace that is below the level of where your evaporator is that the water can drain into? Well, they make something that can help you, which is available for sale on our website. It's called a Condensate Drain pump. It's a little box which mounts up against your furnace or your air handler. The water drains into it, and then it has a pump that allows you to hook a tube up, and you can run that tube wherever you want. You can run the tube up along the ceiling and then over to perhaps a sink that you have in your basement. So if you don't have a floor drain, you can use the Condensate Drain pump. The instructions for installing that pump are included with the product. Okay, we're just about done with our project. You almost have central air conditioning installed. Now when the contractor does his portion, when he's finished, you'll want to tidy up any loose ends, such as filling the hole that you cut in the side of the house. Now I'm going to do that with this particular job with some product here. It's a clay-like product called thumb gum. You can use anything such as caulk or can of foam, whatever will make a nice weather-tight seal. What's it going to take to finish this up? Your contractor is going to finish the last part. What's he going to do? 4 basic things. Solder the copper refrigerant line connections, which you have already put in place. Connect the high voltage wiring to your home's main circuit panel, which you've probably run, as we've shown in the video, most of that wiring already. He's going to pull a vacuum on the refrigerant lines with a vacuum pump. It's going to pull all the air out of them, and then release the refrigerant from the air conditioning unit, the condenser out in the yard, into the system, start the system up, and balance the pressures. And then he's also going to inspect everything that you've done to make sure it was done properly. And that's it. You're now the proud owner of Central Air Conditioning. And congratulations on doing a great job. Well, we really appreciate you shopping with us at Alpine Home Air Products. Thank you. I want to make mention of a few things that you should be careful of when you're doing this project and keep in mind for safety reasons. 1, always wear proper safety gear. Follow local and national codes as pertains to this type of work. Get local permits if necessary. In some areas, that's required. Find out and do so if you need to. Do not handle refrigerant unless you are certified to do so. As we recommend in this video, at the end, call out a contractor to take care of that. The Environmental Protection Agency of the United States requires you be certified to handle refrigerant. Do not handle high voltage electricity unless you're an electrician or you're experienced to do so, as we show you in this video. And lastly, keep in mind that sheet metal can be sharp, so be careful not to cut yourself.